So today we will be discussing what are the operations that can perform on multiple random variables. Okay. So the first operation that can be performed on multiple random variable is mean of a function of multiple random variables. Okay. So here we have considered two random variables x and y are the two random variables. Okay. Now we have taken a function g which is function of these two random variables. So it is g of x comma y. So what is our interest? Our interest is to find out mean value. So how do you represent mean value? G bar. G bar is used to represent mean value, that is equal to expected value of, so mean is nothing but what? Expected value of g of x comma y will give you mean value. So since we are considering two random variables, here we have to consider what is the joint probability density function. Okay. So since if it is more than two random variables, you have to consider joint probability density function. The joint probability density function is denoted like this: fxy comma x comma y. Now, what is the formula for mean value? It is given as, since you have two random variables, you have to use two integrations here. So it is integral minus infinity to plus infinity, integral minus infinity to plus infinity. The function, whatever function is given, so it is g of x comma y, and the corresponding probability density function fxy of x comma y, and we have to do integration with the random variables dx and dy. Okay. So using this formula, we can find out what is the probability, what is the mean value of a function of two random variables g of x comma y. Okay. Now, we will discuss what is join movement. So the second operation that can perform on random variables is join movements. Okay. So just number join movements. So in this we will be discussing two topics. The first topic is the join movements about the origin, join movements about the origin, and join movements about the mean. These are the two topics we will be discussing. Okay. So first we will discuss what is join movements about the origin. So the join movement about the origin. So it is that here also we will be considering joint means what? We have to consider two random variables. Here also we will be considering two random variables x and y. Okay. So the joint movement about these random variables is nothing but the expected value of, what is joint movement about the origin is nothing but expected value of x of n, y of k. Okay. How do we denote this? We denote it as m and k. So m and k is expected value of x of n by power k. Okay. So this what is this m plus n? M plus k. Sorry, n plus k is nothing but order of the movement. Okay. So for example, if your n is 1, k is 0. So what is that? Both are 0, 0. M0 and N is 0, both are 0. What is that we get? It is expected value of x power 0, y power 0. So it is 1, expected value of 1. It will be equal to 1. So it means that 0th joint movement about the origin will be always 1. Okay. Similarly, now we take n is equal to 1, k is equal to 0. If you take n is equal to 1 and k is equal to 0, so that is nothing but x power is 1, y power is 0. So that what is that we get? Expected value of x is nothing but the x bar. Okay. And similarly, if n is 0 and k is equal to 1, so we will be getting 0 and 1. So what is that we get? Here expected value of y, that is nothing but y1. Okay. So if you add these two, 1 plus 0, it is 1. No? So what is this? It is called the first order joint moment about the origin. So what is the first order joint moment about the origin? This gives you the mean value. So it gives us x bar and y bar. Okay. Now similarly, if you find out the second order movements, that is m20, means what? X power is 2, y power is 0. So it is expected value of x square. Okay. So this gives us the mean square value. So this gives us mean square value. Similarly, m02 will give you what? The mean square value of y. So it gives us mean square value of y. And similarly, m11. So if you add n and k, 1 plus 1, it also gives you 2 only. So all these are second order joint movements. These are second order joint movements about the origin, whereas these two are the first order. These two are the first order. Okay. So if n is equal to 1 and k is equal to 1. So what is that gives you? It gives you the expected value of x1. It gives us the expected value of x1. Okay. So this is the joint moments about the origin. Okay. Now in this, we just discuss what is M11. What is M11 is the expected value, second order joint movement about the origin. Okay, M11 is what? Second order joint movement about the origin. This is also called correlation. What is correlation? Correlation is second order joint movement about the origin. Okay, so that is M11. So it is expected value of x1. How do you denote? This we denote it as Rxy. Rxy is equal to M11, that is equal to expected value of x1. What is the formula? Since we are using two random variables, the formula is integral minus infinity to plus infinity, integral minus infinity to plus infinity. Okay, write the function. What is the function we have? Xy and the probability density function. So since we have two random variables, we have to consider joint probability density function dx dy. Okay. And similarly for discrete case, this is for continuous case. Now if you take discrete, what happens? Instead of integration, we will be having summation. Since we have two random variables, we have to consider two summations here. It is given as, for discrete case, Rxy is given as summation with respect to n, summation with respect to n, xm, yn, pxy, xm, y. Okay. So this is the correlation in the case of discrete. Now we also discuss what are the properties of correlation. The properties of correlation, the first property of correlation is that, okay, the first property is that if x and y are statistically independent, then this x and y are said to be uncorrelated. Okay, so if x and y are independent, then what is x and y? X and y are also uncorrelated. Okay, so this is the condition. Okay, so what is Rxy? Rxy will be equal to expected value of xy. So it is that expected value of x into expected value of y. Because what is that? X and y are independent. Statistical independence means what? Expected value of xy is equal to expected value of x into expected value of y. Okay. So Rxy will be equal to what? Expected value of x into expected value of y. So what is expected is nothing but x bar. Expected value of y is nothing but y bar. That is our first property. Okay. Then the second property says that if x and y are orthogonal, then their correlation will be 0. Okay. So what is that? Second property is that if x and y are orthogonal, then what is Rxy will be equal to 0. Okay. These are the two properties of correlation.